These are the lesson 4.2 extension notes. We're looking at slopes of parallel and perpendicular lines. I think this set of notes is a little fiddly. It is not my favorite, but we are going to do it anyway. So the key idea when you're looking at parallel lines and slopes is that lines in the same plane that do not intersect are parallel lines, right? You already know that. Non-vertical parallel lines have the same slope. Non-vertical parallel lines have the same slope, all right? They can be positive, they can be negative, or they could be horizontal, because if they're horizontal, then they would have the same slope, which would be 0. If they are vertical, like the little grid marks here, all vertical lines are also parallel, okay? So identifying parallel lines, you can look at these lines and you can see, well, you might be able to figure out whether they're parallel or not, but sometimes it's hard to tell. They look pretty close, right? Plus, you always have to do the math, right? So I'm going to do this one in purple. I'll use some different colors to kind of color code it. Okay, so my line 1, I have 2 points on there. I have -3, 2, and I have -4, -2. -3, 2, -4, -2. All right. And so to find the slope, I want the change in the y over the change in the x. So my y values go from 2, which way do I want to go? I don't think it matters. We'll do 2 minus -2. So the change in the y is 2 minus -2. Okay, and over the change in the x, -3 minus -4. And because I'm working with signs, I always double check my work over and over, right? So I want change in y, change in x, my y's. +2 minus -2, -3 minus -4. Okay, everything's written down right, so I know that I need to change this. It's the same as 2. 2 minus -2 is the same as 2 plus +2, so that's 4. And -3 minus -4 is the same as -3 plus 4, which is +1. So my slope, I believe, is +4, and that seems reasonable. It's going up, and it's going up pretty steeply. All right, let's switch colors here. Let's do line 2. Maybe I'll label it. And its points are 1, 3, and 0, -2, 1, 3, 0, -2. Okay. It doesn't matter which point you write down first, and it won't matter which order you subtract as long as you're consistent. All right. If you do this minus this and this minus this, that'll give you the same answer as this minus this and this minus this. Okay. So that's nice. All right. Now I'll do the same thing. M equals the change in the y value over the change in the x value. And the y's, let's go 3 minus -2. And the x is 3 minus -2, 1 minus 0. Hey, that one was easy. Okay, 3 minus -2 is the same as 3 plus +2, so that's 5. And 1 minus 0 is 1. So these two do not appear to have the same slope. And if I look at it, that one does look like it might be a little bit steeper, huh? Right. Let's go to line 3. All right, let's see, 3 is 4, 1, and 3, negative 3. Slope is the change in the y value over the change in the x value. The y's are 1 minus negative 3 over 1 minus negative 3, 4 minus 3. All right. 1 minus negative 3 is the same as 1 plus positive 3, so that's 4. 4 minus 3 is 1. So after I do the math, I can see that line 3 and line 1 have the same slope. So line 1 and line 3 are parallel, but line 2 is a little bit steeper because its slope is 5. Oh, sorry. Slide that up a little bit. Okay. Then you have a similar U-try, and even if you can look at it with your eyeball and tell which one doesn't fit, you still need to do the math. You still need to prove it. Okay, at least example 2 is super easy. Are the given lines parallel? Explain your reasoning. If I have y equals negative 5 and y equals 3, let's do a little sketch so we can visualize that. If I have a y is negative 3, negative 5, that's down here, right? That means if x is 0, it's negative 5. If x is 1, it's negative 5. If it is negative 2, it's negative 5. All right, so this is a horizontal line for y is negative 5. And yes, and it is a horizontal line for y is equal to 3. And we can see that they have the same slope, which is 0. We should write that out. So they are parallel. Okay, so you can either memorize that horizontal lines have a slope of 0 and all horizontal lines are parallel, or you can figure it out every time. You just sketch a little picture. Sketch a picture in your brain where you're visualizing y equals something, another y equals something. Oh yes, those must be parallel. Okay, and now you have a similar idea with x values, which will go back, I think, to, see, vertical lines are, yes, which is going to go back to your key idea that vertical lines are parallel. Okay. All right, now we have a little geometry one. See, it's this one little problem, and then it just goes on and on. Okay, the vertices of a quadrilateral are this. And how can you use slope to determine whether the quadrilateral is a parallelogram? Is it a parallelogram? Justify your answer. Right, so I'm going to start by just making the x and y axis in the middle here and plotting my points because it'll help me to visualize that quadrilateral. So A is negative 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. Okay, and B is 2, 2, 1, 2, 1, 2. And C is 4, negative 3, 1, 2, 3, 4, 1, 2, 3. And D is negative 2, negative 2, 1, 2, 1, 2. Seriously? Is that right? 1, oh, no, negative 2. 1, 2, 1, 2. Maybe it is. Okay. I'm going to go ahead and connect those so we can actually see it. That looks a little funny to me. I'm just going to double check and make sure I've got that right. Negative 5, 3. 1, 2, 3, 4, 5. Yep, that one's right. 2, 2. We know that one's right because we checked it. And 4, negative 3. 1, 2, 3, 4. 1, 2, 3. Okay. Would hate to do all the math and then have it be wrong. All right. So in order for these to be a parallelogram, I'm going to have to find the slopes of all the lines. And then if AB is parallel to DC and AD is parallel to BC, then it's a parallelogram. All right. So let's do, I'm going to kind of do them in pairs. I'll do AB. All right. Put the line over it. Let's see. So the change in the y's over the change in the x's. So for A, the y value is 3 and B, so I'm going to do 3 minus 2. And the change in the x's is negative 5 minus 2. 3 minus 2, negative 5 minus 2. 3 minus 2 is 1. Negative 5 minus 2 is negative 7. All right, and then let's do DC. All right, let's see, here's DC, and it doesn't matter which order I go in, so I can say 4 minus, change in Y, negative 3 minus negative 2. Negative 3 minus negative 2 over 4 minus negative 2. All right. Negative 3 minus negative 2 is the same as negative 3 plus positive 2. Negative 3 plus 2 is negative 1. And 4 plus positive 2 is 6. Oh, that does not look parallel. All right. And let's go ahead and do the other two. Okay. So already I can tell that this is not a parallelogram, right? Because AB and DC do not have the same slope. They're close, but they're not quite. And I'm going to draw a line there to separate those two. All right, and we'll just keep doing it for practice. All right, so we'll do AD now. No. AD, and we need to compare AD and BC. Okay, change in Y over change in X for A and D. Can you see it? Okay, so AD. Change in Y is 3 minus negative 2. And D. 3 minus negative 2 and negative 5 minus negative 2. Okay. 3 minus negative 2 is the same as 3 plus positive 2, so that one's 5. And negative 5 plus positive 2 would be negative 3. Okay. And BC. At least it's good practice using our slope formula, huh? Okay, BC. See, change in Y, 3 minus, or sorry, 2 minus negative 3, B, C. 2 minus negative 3, 2 minus 4. And that is 5 over negative 2. And again, we see that they are very close. They're both negative. They're going down. They're both negative. These other ones were also going down, so they're negative. We leave it as an improper fraction, but you can see that the fractions are not the same. So it is not a parallelogram. If these two numbers had been the same and these two numbers had been the same, it would have been a parallelogram. We might look just a little bit. A much easier way to see, let's see, is that to get from this point to this point is going back 1, 2, 3, and up 1, 2, 3, 4, 5. And to get from here to here is back 1, 2, and up 1, 2, 3, 4, 5. So because the little triangle isn't the same here and here, you can tell that they are not parallel. You can do the same thing here. You can see that this is a change in 1. The rise is 1 and 1, 2, 3, 4, 5, 6. And this one is 1, 2, 3, 4, 5, 6, 7, and 1. So you can see it in the picture. So if you have a picture, it might be easiest to count. And if you have numbers, then you can work the problem. Yes, it's the set of notes that just keeps giving. All right, now we're going to look at perpendicular lines. Perpendicular lines are lines that cross at a 90-degree angle, okay? Two non-vertical lines are perpendicular when the product of their slopes is -1. Okay, this is kind of a big idea that you need to remember back, that when you multiply reciprocals, that makes that the product of reciprocals is 1. Like you have 1 over A times A over 1. Those are reciprocals. And when you multiply that, you end up with A over A. So that equals 1. Okay, so this is telling you that they are perpendicular when their slope is -1. So they need to be opposite. The sign needs to be opposite reciprocals. So all of those words will break down to, one of them will be like A, and the other one will be -1 over A. So they have to have the opposite sign and flipped over, okay? Or it could be, maybe it's two fractions, and you'll have like A over B, and the perpendicular will be -B over A, okay? Flipped over with a negative sign, okay? All right, so let's do it. We've got these 3 lines, and we have to pick out which 2 are perpendicular. Well, you know it's this one, and is it perpendicular here, or is it perpendicular here? Oh, the other thing, vertical lines are perpendicular to horizontal lines. That makes sense. All right, so anything that crosses on a grid is going to be perpendicular. You already know that. Okay, so let's just do it. Let's just call this guy 1, and we'll do line 1 here. Let's see, and my points are 0, 5, right? And what's the other point on here? -2, 2. Yep, 0, 5, -2, -2. Okay. Yeah, I have change in the y over the change in the x. 5 minus negative 2 over 0 minus negative 2. 0, 5, negative 2, negative 2. 5 minus negative 2, 0 minus negative 2. All right. 5 plus positive 2 is 7, and 0 plus positive 2 is 2. So the slope of this one is 7, 2. That means I would go over 2 to change in the x, and up 7. 1, 2, 3, 4, 5, 6, 7. Yes. All right. Let's do this guy. Line 2 is negative 5, 0. And 2, negative 2. Okay. Change in y. Change in x. 0 minus negative 2. Negative 5 minus positive 2. 0 minus negative 2 is 0 plus 2, which is 2. And negative 5 minus 2 is negative 7. Ah, I already found it. Look, it's flipped over, and the sign is different. So these two are perpendicular. They were out of room. Okay. I think I forgot to write it on the first. Well, you can see the first one. All right, let's do the other one just for extra practice. Let's see. So for line 3, we have negative 5, 6. All right. And 1, 4. Change in y. Change in x. 6 minus 2. Oh, sorry, 6 minus 4 equals 2. And negative 5 minus 1 is negative 6. This does have to be simplified. So that is negative 1/3. And you can see that 1/3 is not the same. I guess you can see there that those are close, but they are not the same. Okay. You have one you try. And then an easy example 5. If we have an x value, if x is equal to negative 2, that is a vertical line. And y equals 8 is a horizontal line. And I know that anything that crosses at a grid point, all horizontal lines are perpendicular to all horizontal, whatever I said. All verticals are perpendicular to all horizontals, right? So this is perpendicular. And then you have one where you have two x values. So you have to decide whether those are perpendicular. Okay, one more. And there's no you try with this one. This time you are doing that same vertices of a parallelogram thing, but we're trying to use slope to determine whether the parallelogram is a rectangle. Okay, so let's do the same thing. Let's draw. Right, let's plot our points. J, K, L, and M. Okay, J is negative 5, 0. 1, 2, 3, 4, 5. There's J. And K is 1, 4 over 1 up 1, 2, 3, 4. And L is 3, 1, 1, 2, 3, 1. And M is negative 3, negative 3. 1, 2, 3, 1, 2, 3. All right, let's draw those lines. Well, to my eyeball, it looks like that is probably perpendicular. That looks pretty straight. Maybe not. That might be a little off. So let's do the math and find out, okay? So in order for these to be a rectangle, this needs to be a right angle. So we need this line and this line to be perpendicular. Okay, got to check and make sure that that all our lines are perpendicular. So let's do J, K. Let's see, so J and K. We've got change in Y, change in X. You see that? Okay. The Y's are 0 minus 4. And the X's are negative 5 minus 1. 0 minus 4 is negative 4. Negative 5 minus 1 is negative 6. It's JK. Let's compare that to JM. Okay, here's J and M. So the change in my Y value is 0 minus negative 3. 0 minus negative 3. Okay, and the change in my X value, negative 5 minus negative 3. 0 minus negative 3 is 3. And negative 5 minus negative 3 is the same as negative 5 plus 3, which is negative 2. And I need to simplify this. So the two negatives cancel out and make a positive, and this becomes 2/3. So I shouldn't have marked those in. So 2/3 and 3/2 are reciprocals and they have opposite sides. So it is true that JK, this one, and this one are perpendicular. All right. Let's check out KL. I might have to white out some of my little signs there. Okay, K and L. That's these two. My Y values are 4 minus 1. And my X values are 1 minus 3. 4 minus 1 is 3. 1 minus 3 is negative 2. Okay. And let's see. So we're comparing KL with JK, since these, and those are also perpendicular. Okay. Which also means that JM and KL are parallel. So these guys are parallel because they have the same slope and they are perpendicular to JK. And I think that probably means that the fourth point has to be perpendicular as well. We'll check it out. What's my other point? ML. Okay. Let's see, where's M and L? Here they are. Okay, so I've got 1 minus negative 3 and 3 minus negative 3. So this is the same as 1 plus 3, which is 4, and 3 plus 3, which is 6, which simplifies down to 2/3. Okay, and so maybe we can kind of group them like this, and group them like this, and we can say that yes, they are perpendicular. The symbol for perpendicular is like that, and so it is a rectangle. Okay, there you have it. Thank you for your patience.